All right, Algebra 2, we are going to delve into graphing these quadratics. We kind of took the chapter and did all the solving, all the neat stuff with it. And now the only thing you know about the graph is when we solved, we actually got the x-intercepts. So we have worked almost primarily trying to make everything into the standard form. So that's what you are used to, right? A, B, and C. And we're going to have some connections here. A is going to stay A, but that's it. The next things we're going to do is identify the vertex, which is HK, and that's how we're going to translate some things around. The axis of symmetry, x equals, because remember Vux, okay, that means a vertical line, undefined slope, x equals, that's going to be H. So that's exactly the same thing here. So we're going to keep recycling that. And what happens is we're going to get 0 and C, if it's in standard form, this C value, because if I put in 0, anything with an x goes away. But notice I don't have that in vertex form, so we're going to have a different way to work on graphing that, and that's what we're going to work on first. Okay, so here's what we have. There's actually nothing else going on, so this is like plus 0. So we're going to start right at the origin. It doesn't move left and right. It doesn't move up and down. We know it's going to be a u shape because it's an x squared, and this a is 1/2. And what that means is essentially we're going to go up 1 and over 2, and its reflection, and that's enough to get us the shape. So we're going to take the normal u shape and we're going to make it a little bit wider, right? So we call this a vertical compression, or a VC of 1/2. So to us right now, what that means is it should be squished, right? So normally it would be a nice tall u. It's been squished just a little bit, but it still opens up because A is positive. So these are all the things we're going to talk about in the next couple lessons here. The next one is still, it's like plus 0. We're going to use the -2 almost like a slope, so down 2 and over 1, and its reflection. So we're going to go down 2 and over 1, and that's enough to get us the shape. It is upside down, right? That's an x-axis reflection. And then we also have the fact that A is 2, means it should be, instead of that U shape, it's going to be squished just a little bit. Okay, and that's a vertical stretch. Okay, so that's getting a lot of vocabulary early, just so we start to get used to it. Okay, so here's all those words again. Okay, so if it is positive, that's what we have right here. It's going to open up, right? Pretty easy to remember. Positive people smile, and negative people, they don't, right? They frown. All right, if A is greater than 1, we call that a stretch, vertical stretch. Okay, so that means it's a little bit taller. And if it's between 0 and 1, okay, so then it's going to be a compression, right? It's been squished, so it's a little bit wider. Okay. Either which way, we're talking about a vertex, and the vertex is either the highest or the lowest point, depending on whether it opens up or down. And that's going to be the key to the vocabulary. Is I may not ask you for a vertex. I might ask you for the minimum value, or I might ask you for the maximum value. So it's going to be a play on the vocabulary. So just remember the vertex is equal to either the max or the min, and how we deal with that. All right, so some things that we have talked about is how to translate some of these things. So if I have the x squared and then I have -5, what's going to happen is we're going to take that u shape, right, because it's x squared, and we're going to move it down 5 units. Now, if I keep it inside here, we're going to take the u shape and we're going to move it. It looks like minus, so it looks like left, but it's actually going to be right 4. Remember, the inside is going to be left and right, and it's opposite of the way it looks. The outside is up or down, and it is true to the number that you see. All right. So we're going to put those two ideas together. We dealt with this primarily with the absolute value, but you can still, we have an inside part and an outside part as we take a look at the next step. So I'm going to look in here. It says -4, so I know I'm going to go to the right 4. So that means the vertex is at +4 to get started with. The -2 means down 2 units. That's -2. All right, so that takes care of the vertex. The axis of symmetry, so that means I'm going to do x equals the x value of 4. Okay, so I might say axis of symmetry, the maximum or minimum value. So here we're going to key in on the very beginning here. This is +3. So if it's +3, that means it opens up. So I'm going to draw a picture of that. And if it opens up, then it clearly has a bottom. So that means it's going to be a minimum value. So minimum value. The domain, its parabola is going to go left and right forever. So it's all real numbers, just like the absolute value. The range, however, we're going to use y compared to -2. Notice where I pulled that down from. Remember, the minimum value is the vertex. So y is compared to -2, and we know it opens up. So everything's going to be greater than or equal to -2. So it takes care of all of those things. We know it opens up. The only other thing we can ask, if the a value is 3, remember that means it should be taller. So it's a vertical stretch of 3. So it takes care of those ideas. All right, we're going to run through all that one more time with the next problem. So hang on to your seat here. The vertex, right? So I know it's going to move to the left 1. So that means the vertex is at -1. It goes up 4, so 4. So we have the vertex taken care of. The axis of symmetry, x equals -1. We're using this number right here. That's the axis of symmetry. It opens down, so it's a frowny face this time. So it has a maximum value. The domain is all real numbers, and the range this time compared to 4, right? We're using the y value, and we know that it opens down, so all the values are going to be less than or equal to that 4 to answer all of those questions. All right, so let's actually use this thing. So instead of giving me all the information, we're going to say, let's make a graph out of this. So I know we're right 1, we're up 3, and that is definitely a point, right? That's the vertex, 1, 3. So I need that point right here. I'm also going to go ahead and put a vertical line in here because that means that's the axis of symmetry. So that has to be the middle of my parabola because we haven't graphed it like this before. So what I'm going to use is down 2 and over 1 and its reflection. And then we can go ahead and put in the rest of the graph. So one thing I want to make sure of in the very, very end, this is a negative. Is my parabola opening down? You betcha. Okay, so it means I have graphed it at least in the right direction. Even if I messed up and I moved it to the left instead of the right by accident, I'm at least going to get some credit for getting the idea that it is a negative parabola, so it should open down to take care of those major ideas. All right, so we'll do more of that obviously in class. The only other thing I need you to do is solve for A. Right, so what we're going to do here is we're going to give you vertex, so that's H and K. So H and K are going to get plugged in. And we might give you another ordered pair. In this case, it's been given to you based on the graph over here on the right. Okay, so they've devised the fact that x is 9 and y is 4 because 9, 4 is this point right here. So we're looking across the graph trying to find a nice point here. So here it was. So this is a regular point. The vertex, right, the highest point that we had, that was 3, 7. So we have all these things and we can label them. This is H, K, X, Y. And what we're going to do, the only thing left then is the A value. So we're going to solve for that. So you can see here, we subtracted the 7 away and we did it 9 minus 3 is 6. 6 squared is 36. And then we finally divided and we got -1/12 in the end with all of this. So a couple ideas here. Does this parabola open down? Yes, so it should be negative. And it seems pretty wide, so that 1/12 gives us a very good idea about it. So what we're going to do is then plug that in along with the vertex. So we're left with x and y in the equation. Okay, so that's just kind of a place where it can be used here, talking about dolphins. Let's take all the dolphins out of it because they're cute and all, but we're not going to use that in every single problem. So here's what we have: h, k, x, y. So if you need to, it's y equals a, x minus h, the whole thing squared, plus k, right? That's way at the top. Remember, this is the vertex form of the equation. So we're just going to plug everything in here. What's y? Y is 1. What's a? That's what we're going to solve. X is 6. 6 minus what? -2. Okay, double signed. We're never going to do that again, right? That's going to become +2. And it's +5. So we have all these things. So let's clean this up just a little bit, because it is algebra 2, for goodness sakes. 6 plus 2 squared plus 5. Here we go. So let's go ahead and get rid of the 5. So we know it's negative 4 equals a times 8 squared. If you went ahead and made that 64a equals negative 4 and divide by 64. All right, now I find a lot of students get this a little bit confused, right? If I just want to try and reduce this fraction, right, I can do 64 divided by 4, even though it's backwards, and I'll find out that this is negative 1/16. So by doing it a little bit backwards, I can find out the fraction. Otherwise, do 4 divided by 64, it's going to be a decimal, and then hit your math button on your calculator, switch it back over to the fraction, because we would like to see this as a fraction. Okay, so let's go ahead and drop things back in the equation. Y equals negative 1/16, x minus negative 2. So we're not going to do that, right? Plus 2 squared and then plus 5. All right, now I understand this is relatively new or brand new to a bunch of us here. Hopefully in Algebra 1 we talked about quadratic a little bit, so the idea of slope along with that a value should be familiar. But I just want you to think about what's happening here. We're going from a y value of 5, 1, 2, 3, 4, 5. Let me make a little bit of a visual. All right, it is at negative 2, 5, and we're going to go to 6, 1, 2, 3, 4, 5, 6, 1. Okay, so if this is the vertex and this is the point, should a be negative? Most definitely, right? Okay, so negative is definitely going to be happening, and I can do this just by looking at the y value. So I'm trying to give you a lot today because I know you guys can handle it. Okay, so if my vertex is 5 and the point is 1, that means it has to be going down, which means I do expect this a value to be negative when I solve it. So I'm trying to highlight it in so many different places. I hope that's not distracting you. But to show you that we want to make sure we have some of these major ideas in place. All right, that's all I got for tonight. If you're doing pretty good with this and you're in my class, then you can get started with some of these homeworks. Otherwise, I'll probably cut them up so you have a little more space, because I know that helps here in our digital world these days. All right, peace.